Okay, right here we're sitting near a fireplace that I made and designed. It's pretty much a wood stove, and instead of using an electric fan, when the power goes out, the electric fans go out and you can't use your wood stove. So I decided to go around that. And this one sucks air in through the bottom. It goes in, and it's corrugated steel, so it's double-sided, and then it has fins in it to transfer the heat better. The heat comes up through here and out. These pipes here go through this and into here. Also, the corrugated part goes through both sides and the back and comes up through here. I did it also to boil water and bake a good pizza up on top. But what this design has, oh yeah, while it's burning, I can also, I put this here so that I can clean it out. While it's burning, I can clean out all the stuff and I can keep it going continuously. It works for this. I got a good smoky mix in here. And as you can see, you know, after the vortex wave starts going, the heat's rising up, and there's a steel plate up underneath this with a hole right here. So all the air is going up this hole, through this part of the fireplace, and up those chimney holes. And what this is doing is it's creating a vortex wave, and it's keeping all the smoke in. So by having the smoke go to the top, come this direction, and then up, it's creating the fresh air coming down here and going in this way. Actually, it works better with this closed. Normally when I clean this out, all the doors are closed. But what I'm going to be going over today has everything to do with vortex waves. And I'm definitely looking at photons as vortex waves, and the more I look at photons as vortex waves, the more sure I am that that's the right way of looking at it. I can't seem to disprove it. What I'm going over now is lensing, electromagnetic lensing through propagation of material, through the interaction of vortex waves. And the theory that I came up with 35 years ago, before I had a stroke, for 35 years I thought that theory was right. I had it in my mind that it was right, and I alluded to it many times that this is the way it's found, and I actually push my theory a little bit farther and do some paperwork on it, and I end up proving it wrong. But yet I'm not really throwing it out, and I'll go over the reasons why shortly. And the reason why I believe in this idea, even though what I worked through here failed and my idea of how to get it back then failed, is back when I was a photographer at age 13, I did a lot of sports in the telephoto lenses. When you get over the 400 millimeter range, looking down fields, the heat, the airflow, the heat that increases or gives waves and airflow, I found it doesn't really separate the wavelengths of light, but it does bend it. And so this heat is pretty much a lensing of itself, and it's a lensing due to the density change of the air. So electromagnetic lensing is field lensing. This effect is between magnetic fields and the positive and negative charges. Proven belief in modern physics. Photon electromagnetic lensing is a charge interaction. As a photon passes a charged particle, the charges between photon, oh good grief, no, I have not spell checked any of my work really, and charged particles interact. Though commonly accepted that 1. Photons have magnetic properties, 2. Like charges attract, 3. Unlike charges repel, 4. The solar winds are charged particles that have a particle density proportional to 1 over r squared. That means as they leave the sun, they're going outwards and they're becoming less and less dense, and this density change is just that. It is a density change, or in this case it is a charge-charge density change. So right here is where I see the failing of this particular direction I'm going with it. And I'm going to keep going for reasons that will become clear later. Yeah, disprove my photon. It is not the same as photon drag, and right here is the best why. Hydrogen plasma of solar winds. The best information I can get on it is that it is a positive charged hydrogen plasma ejection. And as a photon goes through it, if we look at it from the double helix side, and the idea that one wavelength, doesn't really turn much from atom to atom, and this may not be the case because here the atoms might be far enough apart where the wavelength does a complete total turn before it gets from one to the other. But the idea is that if it has a positive, the reaction is going to actually push it away from it. And if it's a negative to positive, it would pull, the two of them would be greater than the one, or the higher density would pull it towards it, and that they would counteract each other. Moving on. Even though photon electromagnetic lensing idea failed, I'm still not throwing this thing out. And the reason why is index of refraction. As photons hit denser layers of the sun's atmosphere, refraction would take place. That's pretty much a given. Best example I could find, but it was not a complete example, was on the YouTube channel Fermilab, and it was under why does light slow down in water. What they did is they went over possibilities. They debunked two of them and then went with the idea that it was electromagnetic properties only. And the idea that light was going back and forth, it sounds right, but it's easily debunked. And it's not so much light itself. What I'm seeing is not so much light itself going back and forth, but the actual two parts of the helix of the photon traveling back and forth. Okay, since I'm hunting for gravity with low energy photons being the cause, I am needing quite a few things, quite a few properties to be true. I'm needing photons to only interact with photons at the point of contact. That means as waves travel across each other, they add or subtract from each other. And as they go by, they have their own, they're pretty much not changed. As in, once they go by each other, they go by each other. Pretty much like waves in water. They only change form, direction, and magnitude when the medium changes. So if they run up against, say, a log in the water, if the wave's running up against a log, so if it's a small wave, it bounces off. If there's two waves there, those two waves can create enough energy to raise the log up, and when the log comes back down, it sends a larger wave, the power of the addition of both those waves in that direction. We see this a lot in some crystal forming, where we can take two photons of low energy and they actually add them together to make a higher energy photon. So there are properties that we see in this form. Number two, if gravity is a photon, and this is a big if right here. Yeah, let's double line that one. If gravity is a photon, then a photon does not change a wave's direction, disproving gravity lensing. So if I'm looking at this from the point of view, if I'm hunting gravity from the point of view that gravity is a small energy photon, or an extreme density of low energy photons, then these properties need to exist. So going on to a WAG, which is a wild ass guess. Photon speed is the center of the vortex wave. The other WAG, as wavefronts propagate through each other, they get bigger and or smaller. So what's happening is we have a photon, double helix, and as it's traveling, one will be positive, one will be negative. So at regular energy, they have a distance of this far, and when it hits, it runs into a well that draws adds energy to the photon, then the photon actually gets smaller. This distance here gets smaller. So it's not that the entire photon is zigzagging through the property, but the zigzag is happening between the center points of the two parts of the photon as they come together, as they expand, come together and expand. And what I'm saying is when it slows down through glass or other substances, this path right here is maintaining a constant speed, a constant velocity of c. And then this path here, so it's velocity c times the distance change of the direction. So when it comes back out and when it leaves the glass, and this is the biggest problem with the theories that we have now, when it's leaving the glass, the photons are not gaining energy to get back to its regular velocity. What's happening is the photons are just changing direction to no longer being affected by the energy waves in a high density medium, and the photon comes out at the exact same way it came in, and as a wave it's traveling in the same direction and such and so forth. The model I have for the double helix twin and opposite turning vortex waves places the center of the plus and minus wave at 5 times 10 to the minus 10th distance from each other to its wavelength. So what I did on the first videos that I did on this thing was amplitude, and I came up with 2.5 times 10. And the amplitude is pretty much the radius of 1. So you have to double it to get the distance between the two vortex centers. So what is the actual size of a photon? Well, if you're looking at the electromagnetic effects, each photon is within a shock wave infinite. Now, whether or not a photon affects a photon's direction going this way would affect something 10 million light years, or have an effect 10 million light years from now, I have no idea, but the effect would be tiny, instant. I mean, just absolutely tiny. So this wave that's going around this, each one are going in opposite directions, so that this is spinning this way and that one's spinning this way as the photon's traveling in this direction. And the negative and positive spin makes a full turn, full revolution within the wavelength of the photon. And then you have the diameter of the photon being 5 times 10 to the minus 10th the size of the wavelength. So the photon is actually very, very small, the parts of it that interact. And if you look at the microwave oven, or if you look at any atomic structures between atoms, this will give you the photon that induces it to heat up or to change velocity gives you the distance of the ratio to get the wavelength. And we can get some really, really accurate readings with the wavelength. Okay, if you're wanting to look at this from a particle point of view, then we're going back to the equation for black holes, and I'm going to go with energy in joules, radius, vortex, so energy in joules equals mass times mc squared, E equals mc squared. I'm placing that here. Now we have another problem with E in joules. I need it to be in another form, so I come energy in joules equals Planck's constant times c over lambda, and I replace E with hc over lambda. So the c cancels out, the lambda goes down, and the h stays up. So I end up with this form right here. These three right here are constants, so I work those out to this. So it's r equals 1.6 times 10 to the minus 70 divided by lambda, and that is your wavelength. So the bigger the wavelength, that means also the bigger the diameter between the two photon charges, and the smaller your radius for the inner piece will be. I found that to be interesting. One part that I did miss on this is the photon has two parts to it, a positive and a negative charge, as they go down, and each one of these two parts, I'm looking at the radius of only one of them, so it's 1/2, and that's how I knocked off the two. There are two parts to a double helix photon, and so I'm looking at half the energy involved. And that concludes my paperwork for this one. Okay, so my approach on this one was completely wrong. I don't feel that the actual idea is wrong, and that is because the idea came from observation. Observation as a photographer when I get into the 400 millimeter range, and well, a lot of the 800 to 1100 millimeter range telephoto photography. When you start going out in bright sunshine, you'll see a lot of heat waves, and those heat waves create a lot of distortion, and these distortions would be similar to what you'd be seeing during an eclipse close to the sun. As soon as you get into high density gas waves, the higher density is going to bend them the same as refraction does, so it's going to bend it towards the denser material. And the mathematics of it, I have to get more into modeling the electron. I need to model, oh, we got rain. I need to model quarks also, and once I do that, I'll try and figure out how this modeling affects the vortex waves of a photon. And it'll have to be another video because this one's already gotten a little bit long. And I'll see you on the next one.